When two bodies are in thermal equilibrium with a third body, they're in thermal equilibrium with each other. Well, thermal equilibrium basically means they're at the same temperature. So this rule kind of makes sense. If A is the same temperature as B and B is the same temperature as C, then A is the same temperature as C. Did I say that right? First law of thermodynamics, energy can neither be created nor destroyed, but can be converted from one form to another. And in fact, a lot of what we're going to do in both thermo and a little bit, well, maybe quite a bit, in fluids and statics and dynamics is keeping track of the energy. And so we're going to count on this fact that energy is not going to be disappearing from our systems the vast majority of the time. Our idea of what kind of energy we'll be looking at, of course, will change. But in thermo and fluids, the energy is basically covered by things you might find in Bernoulli's equation. Whereas when we get to something like statics, there will be no energy change because nothing's going to move. And then in dynamics, we're going to find that we're only really interested in mechanical energy, such as kinetic energy, energy stored in a spring, energy due to falling a given height. And we won't, in that case, be interested in temperature and stuff. So in dynamics, which we'll do a little bit of on Monday, you're going to see us talking about conservation of energy. And does this problem involve conservation of energy? Well, energy is always conserved. In dynamics, we're going to be taking a very narrow view of that and saying, does mechanical energy get conserved or not? So this first law of thermodynamics idea is going to actually guide us through a lot of what we do. And there we go, just like that, like magic. The tablet is set up. Great. Now, thermodynamics starts on page 147 of the new book. If you do not have the new reference handbook in front of you, go to the NCES website, log in, and I think the name of the section is called Reference Documents. And you can download the version 10 handbook from within there. It's going to be very useful to you to have your own electronic copy of that. Keep in mind, whenever you do take the exam, the copy of the handbook you have will be on the screen. It won't be a paper book. Well, the nice thing about that is that you're going to be able to use word searches to look through that handbook. So you can type in a search bar. So just like you can search it as a PDF on your desktop, you're going to be able to search it the same way. So we're actually going to focus a little bit of our attention on what are the best search terms, as opposed to sort of what is the page number. So in the thermo section 147, they mention first law as a statement of energy. When we talk about the movement of heat and the movement of energy and the movement of work, our idea for this is basically centers around this thermodynamic idea of a steam cycle that generates power. So in that we have a boiler, and we're going to put some heat into the system. So Q positive means heat coming into the boiler. So that could be the fire burning underneath the thing or whatever. And that's going to generate steam, and we're going to feed that steam to a turbine. And that turbine is going to put work out of the system. And we're going to label those both as positive, but it's important for you to recognize the direction. If we keep in mind everything we do, the sign conventions are based on the steam cycle, then we know work is positive when it's going out of the fluid or the thermodynamic cycle, and Q is positive when it's bringing energy in. For example, we might have to take some of the, I'm not good at drawing turbines. We might hook a turbo pump impeller up to our turbine. And we're going to have to put work into that pump, or whatever kind of pump it is. We're going to be putting work into that pump to move the fluid. That's going to be negative work, because it's work putting into the fluid, that's negative, whereas work we get out of the fluid, spinning our shaft over here, is positive. So that's our sign convention, and that sign convention is going to govern some of the, well, it doesn't govern them so much as we're going to see it in use in several of the equations.